Okay, so we're reviewing for that logs test, and why are we doing this? Because you'd run into problems like that, and you had no way to solve them. And we had to figure out a way to solve them. And so if you've learned anything about how to write logs, etc., you should be able to, with a calculator, give me the answer to this. Please, grab your calculator, figure it out. I will pause while you do. Okay, so hopefully you should have written this as log base 3 of 7 equals x. And that means that log 7 over log 3 would solve this for you. And you got 1.77? Does that sound right? All right, good. So that means that this should be about 1.77. So 3 to the 1.77 should be about 7. It's rounding, so it's going to be off a little bit. All right, so it gives us another tool for solving equations when there's an x in the exponent. And what's that called again when there's an x in the exponent? This kind of form is called something form, exponential form. And when we rewrote it with a log, that's called log form. All right, yes, the base word there is logarithm. Now, last night you did log transformations, and I know that was a little bit harder for you, so I want to go through a couple right now. Would you write this one down? It's really not that hard if you do it step by step. That's one of my favorite things. Just one little step at a time. Okay, so the first step in this kind of a problem is to back off and figure out what the parent would be. The parent of this one would be y equals log base 3 of x. So everybody write that down. And figure out its key points. If you learned anything yesterday, you should remember there were 3 key points. And that the key points are not things you plug in for x, but you instead plug them in for y. And you stick in what 3 simple things? 0, -1, and 1. All right. And then we take those and stick them in. Well, what do you mean stick them in? Well, we put them into the equation. But I'd like to rewrite it as 3 to the y equals x, just because it's easier for me to do it as exponential than logarithmic form. So now I go stick in this into the y spot, which is right there. So 3 to the 0 is what? 1. 3 to the -1 is 1/3. And 3 to the 1 is 3. So now I got my 3 main points. But those are the parent points. But now if I take those, I can make those into the child points, I guess you could say, or the resulting points. So I need to change these guys into 3 new points. This tells me what I should do, and so does that. Now, generally, when you're doing your change, you should go through and do any multiplies first, and then do any add or subtracts. So this one's a multiply, so it's multiplying something by 3. Well, am I messing with x's or y's when I'm in this position? The y's. So I'm going to be doing these numbers and multiplying them all by 3. And then this is going to be messing with my x's, and I'm going to be not multiplying, but adding to. No, I'm not. Why am I not adding to? Counterintuitive. And so I do -2 on all the x's. Would you please do that and tell me what you get for your new set of xy points? I'll pause while you work on that. Okay, so somebody give me those 3 points that you have that are, once you're all done with this. Yes. Oh, 1, -1, and -1 2/3. Can anybody verify those? Okay. And then on the y side?
3, 0.
Can anybody verify those? So anybody have the exact same points as him? And there's a lot of like question marks here. I need to see some more straight A student responses that have got the same thing. You got the same thing? Okay, you got the same thing? All right. Okay, then it's probably right. So we're going to say, if those are my points, there's only one other question they could ask you about, and that's, where is the asymptote, the line that you can never touch and you get closer and closer to? Well, if I graph those quick, over 1, up 3, over negative 1 up 0, and over negative 1 and 2/3 and down 3. Can you see how it's kind of dropping off pretty rapidly as and it always does that, so it's probably going to be one of these that gets closer and closer and never touches right there. But what does it closer and closer and never touch? You're right, it's going to be negative 2. And I'm going to show you why you would have been able to look at this and know that. All right, let's look for a second at some old asymptote stuff. In the past, you had asymptotes like this. Y equals 1 over x. And what couldn't x be, or it would mess everything up? 0. X couldn't be 0. And so there was an asymptote at x equals 0, because that was the one thing it wasn't supposed to be, or it would mess everything up. So that's what causes the asymptote. So let's go back to this and say, what would mess everything up? Well, if the argument here becomes 0, you've got a problem. Let me show you why. If you have a simple one, y equals log base 2 of x. This can be 0, and it's no big deal, because 2 to the 0, or y, equals x. That can be 0, no problem. But why can't that ever be 0? Because when you take a number to a power, this can't be 0 here, because otherwise you're saying you can take a number to a power and make it disappear. And you can't. You give me any number, and all I can do is give you a power that'll make your number really, really small, but I can never make it 0. Unless I start with 0 in the first place. Okay, so the bottom line is this piece, the argument, is the place that gives you the asymptote. So look back at our original problem right there. That's the argument part, the part that comes after the base, right in here. And what would make that 0? Negative 2. And I could have just sort of seen that it was getting closer and closer to negative 2, but never hitting it, by looking at the graph. But that tells me exactly where the asymptote is. X equals negative 2 is the asymptote. All right, I want to have you try another one here. Try that one, and tell me what the asymptote is. You want to tell me the asymptote right now? What's the asymptote going to be? It's going to be 1. All right. So go ahead and graph it. Use the parent point method just to save you time. The parents are the same as last time, right? 0, 1, negative 1. And if we do, if this is log base 3 of x, then this is 3 to the y equals x. And then these parent points are, if y is 0, then this must be 3 to the 0 is 1, 3 to the 1 is 3, and 3 to the negative 1 is 1/3. Those stay the same. It's figuring out the new points that's the harder part. I'm going to pause while you do that. Okay, I told you that there's 2 things going on here, multiplying and adding 1. And you would be smart to do the multiplying part first. So I'm going to multiply all of my y's by 2 and get my new ones. 0 times 2, 0. 1 times 2, 2. Negative 1 times 2, negative 2. Then I'm going to go and not subtract 1, but add 1 to all the x's. 1 plus 1 is 2. 3 plus the 1 makes 4. 1/3 plus 1 makes 1 and 1/3. And then the asymptote was, we already said that, when the argument equals 0, so that must be x equals 1. And so if I were to graph this thing, I'd have a line at x equals 1. That's the asymptote line, right? And then I'd have 2, 0 over 2 up 0, over 4 up 2, and over 1 and 1/3, and down 2. What did I do wrong? Over up there, over 1 and 1/3. Is that supposed to be negative 2? Did I mess up the 4? Okay, oh, 1 and 1/3 isn't, okay, you're right. I was just thinking it was supposed to be over here somewhere, but it's not. 1 and 1/3 is only over a little ways, and down 2. That's what I get for not actually using graph paper, because I wasn't being accurate enough. So there it is. Generally, it's getting closer and closer to that dotted line, and it's going to go forever up this way. And that's time.